getting closer and closer to the end of the year. It seems strange to be doing it this way, and I'd much rather be in a class where we can go over stuff. But here's where we are. In similar triangles, not only are sides proportional, but also the altitudes of the triangles, the medians, and angle bisectors. Perimeters are also proportional. So what that means is that if you have two similar triangles, say this triangle and this triangle, and we have stated that they are similar. We talked about how to find out if they are similar earlier in the chapter. If the K factor is 2, not only does that apply to the sides, so like this side is 3, this side would be 6. That also applies to like the angle bisector. So if this is 4, then this would be 8. But it also applies to the perimeter. So let's say we knew all the sides of one side. So this was a 3, let's say 3, 8, 7. If we were to calculate that all up, we'd say the perimeter, now the K factor is equal to 2. So the perimeter of the first one, P, would equal 18, because 3 plus 7 plus 8 is 18. That's going to make the perimeter of the second one still K factor of 2. Do you know what the perimeter of the second one would be? If you said 36, you're doing just fine. Now think about it. This side here would be 14, and this side would be 16. 8 times 2 is 16, 7 times 2 is 14. Now if we add those up, 16 plus 14 is 30. 30 plus 6 is 36. So that gives you the perimeter of the other triangle. Now, in triangles, polygons, squares, if we talk about area, now area can be calculated by length times width or base times height divided by 2. But if the perimeter keeps the same K factor, the K factor for area will be a squared value for that. So if the squared value or the K factor between the triangles is 2 for the perimeter, for the sides, for the median, the K factor for area would be 4. Again, for if it's perimeter, K equals 2, then the area would be square of that, or K equals 4. So now think about it. If the K factor for perimeter is equal to 6, then for area, it would be, the K factor would be, 36. Doesn't that make sense? 6 squared is 36. Now for volume, it's cubed the proportional K factor. So if right back at our earliest beginning, K equals 2, and for area, it equals 4. For volume, what we're going to do is we're going to take that 2 value and we're going to cube it. So 2 times 2 is 4, times 2 is 8. 2 cubed is 8. So let me spell that out for you again. For perimeter and sides and medians and all that stuff, K equals 2. For area, K would equal 4, because that's 2 squared. And for volume, K would equal 8, because that's 2 cubed. Okay? If we chose a different value, like K for perimeter, K equals 10. For area, K would equal 10 squared, or 100. 10 times 10 is 100. And volume, K would be cubed, so we take 10 cubed. And so 10 cubed equals 1,000. All right? So that's kind of how how the proportional values for perimeter, area, and volume work. So now let's kind of put this into practical application. It says, given the triangle ABC is similar to triangle DEF, the perimeter of ABC is 144, and the perimeter of DEF is 16. Now, if we think back a couple of lessons ago, what we were working on a couple of days ago, we said there's multiple ways to do this. One is to set up a proportion in which we find the K value. So we're going to take the image, 144, and we're going to put it over the pre-image of 16 in order to find the K value. So we'll do 144 divided by 16 gives me a K value of 9. So that means the K value between these two is equal to 9. So it says 12 is to BE. So we're going to divide by 9. So we'll take 12 and divide by 9 to get 1 1/3, or 4 over 3. Or, again, like I said, 1/3, 1 and 0.33333 repeating. Okay, there's another way to do this, and hopefully we'll get the same answer when we do it this way, is to set it up as a proportion. 144, the image over the pre-image of 16, is proportional as 12 is to x. So if you cross multiply, we get 144x equals 16 times 12. All I did was I took the x and multiplied it that direction, and I took the 16 and multiplied it that direction, canceling out the other sides. So now we have 16 times 12 equals 192 equals 144x. Now we divide by 144, and we get x equals 1.333 repeating. Same thing I got doing it the other way. Both ways work. It doesn't matter which one you want, whichever one's probably easier for you. Here's another problem that we're going to work on. It says, given triangle ABC is similar to DEF, we're going to solve for x. I've seen that shirt so many times where they say, solve for x, and then it's got the little arrow and it says, or find x, and they say it's right here. That's where x is. I always get a kick out of those t-shirts. I know it's probably because I'm a math teacher, and that's the only people that find that funny. But we could set this up as a proportion. Again, we could find the K factor, or we could set up the proportion just like we have. Now, if we were to look here, I can probably look and see what the K factor is going to be. Because if I take the image of 8 over the pre-image of 4, I'm going to get the K factor as equaling 2. That's a piece of cake, isn't it, to find K is 2? So now, if I want to find x, I just got to work the exact opposite direction. I divide 6 by the K factor of 2, and x should equal 3. Sometimes finding the K factor is going to be a whole lot easier than setting up a proportion. Sometimes the proportion's easier. And if there's one that you feel more comfortable with, you can use that. So I can also say 8 is to 4 as 6 is to x. Could cross multiply. I'm going to get 8x equals 6 times 4, or 8x equals 24, and x equals 3. Both ways, got the same answer of 3. You could choose whichever method you like better. Let's move forward. Same thing, working on a median here. So you can see DG and AH are the medians of these triangles. And we can, I didn't get too awful creative. The K factor between the two is 2. K equals 2. But that's kind of bad. Looks kind of funny. It probably should have put these values over on the other triangle. But don't always believe the diagram. So we have 24 is to 12 as 10 is to x. So 24x equals 120. 120 divided by 24 equals x equals 5. Or we could have just taken the k factor and we could have divided by 2 because that's what was going on in the rest of the problem, and x would equal 5 that way. All right, hopefully you're getting this concept. It's not too bad. It does get a little bit more confusing when we add in area. If we have the proportion m over n, like we have here, like the pre-image over the image, instead of multiplying just by the simple k factor, we have to, for area, we have to have k squared, or we have to square the numerator and the denominator, okay, like we have here. All right, so I think the next slide that we're going to is going, is going to be with area. So we're going to put this into practice. Now, again, there are two methods to doing this, and either one is just fine. We know that the area of this, and sometimes it's important that we kind of draw out the diagram and set these things up for ourselves instead of just trying to rush through it, is 20 units squared. So we want to find the area of the image. As you can see, they're getting greater, so we should come up with a bigger number. And so if we get a smaller number, we know we're in trouble. There's two methods we can go about doing this. One is we could say 9 over 6 will give me my k factor. I did image over pre-image. I've been saying that a lot this chapter. So 9 divided by 6 is 1.5. 1.5, or 3 over 2. You could look at the k value as being either one of those, and you would be right. You could either say 1.5 or 3 over 2. So if we're applying this to area, remember we got to square that. For area, we have to square it. So if we took 1.5 and squared it, we're going to get 2.25 would be my k squared value, or 3 squared is 9 and 2 squared is 4. So your area k value is either going to be 2.25 or 9 over 4. So if I took 20 and multiplied by 2.25, I'm going to get 45. Now again, just like before, there's two ways to do this. So if we took our proportion, our original proportion, which we saw was 9 over 6, and if we were going to proportionally solve that for area, what we'd have to say is we'd have to say 20 as, excuse me, I did it upside down. It should be image over pre-image. So x over 20. But now remember, that's units squared, so I'm going to let that be the thing that's going to remind me that this has to be squared and this has to be squared in order for that to work. So when I square those, I get 81 over 36 is equal to x over 20. So now I can cross multiply. I'm going to get 81 times 20 equals 36 times x. So 81 times 20 is 1620 equals 36x. Divide by 36 and I get x equals 45. Again, either method gave me the same solution. All right, hopefully one of those will help you out. Maybe try both. You could. That'll be a way of checking your work to make sure that you're doing it right both ways. Now, for volume, if we think about it, we have perimeter, and it doesn't have to be perimeter, it could just be the side. I just use perimeter kind of as a start, an easy place to go with to begin. Area and volume. This is K, or the proportion M over N. For area, it's K squared, or the proportion M squared over N squared. And for volume, it's K cubed and M cubed over N cubed. Now, problem area is please make sure that you, when you are cubing, that you're cubing K. Don't cube the area. Okay, cube K. All right. So here we've got a problem we would like to work on. Is I've got a couple of cubes here, and I'd just like us to take a look here. They're simple to solve cubes for volume because it's length times width times height. So in this one you can see it's 3 times 2 times 1 is 3. And I can see, if I just compare the heights, the K value is equal to 1.5. So now, if I wanted to find the volume, it would be K cubed. And if K is 1.5, and I cube that, that means I do 1.5 times 1.5 times 1.5. I get 3.375. So then if I took my original volume of 3 and multiplied that by 3.375, I get 10.125 units cubed, and this should be units cubed also. Okay, so if I were just to look at this, the other method I could do is I could do length times width times height. If my length is 3, if my width was 4.5, and my height was 1.5, and if I multiply them all together, I should get the same thing. 3 times 4.5 times 1.5 gives me 10.125. 10.125. Okay. So, sorry, I'm just checking something. All right. So that's kind of how we work on these types of problems. Oh, excuse me. I was double checking my work and I saw that there's a mistake here. This should be it. No, that should be a 3. Okay. Excuse me, I'm just kind of double checking something, making sure we're getting this right. Oh, okay. I'm sitting here and going, I wasn't getting the right answer. Yes, this should, if you're checking my work, we go way back. When I calculated this volume, 3 times 2 times 1 should be 6. And then when I was sitting here, I was double checking my work, times 3.375, that gives me 6 times 3.375 gives me 20.25. Excuse me. That you need to double check. Sometimes it's good to double check your work, because when I double checked my work, I saw that I had a little problem, and my problem was this is 3 times 2 times 1. Over here should be 6. If you caught that already, I'm glad you did that, and that gives us a good reason for why you're double checking your work. I was so worried about talking through the video that I missed that this is actually 6, and when I went back and double checked my work, this should have been 3 times 2 times 1. And I'm glad I double checked my work. I often, if I'm doing something specific, I always make sure I double check my work. You would do the same. Do well to do the same. All right? So here we have a similar situation. I want to calculate volume for two shapes. And so for these two shapes, what I want to do is I want to say that if it's 4 is to 6, and 3 is to 4.5, and 7.5 is to 5, my K factor can be found by 6 over 4. Image over pre-image. Okay, so now if I was calculating volume, I know that this K factor is 6 divided by 4, which is 3 over 2, which is 1.5. So my K factor, again, it was the same as the last one, 1.5. So my K cubed value for volume is going to be that cubed, which again is 1.5 times 1.5 times 1.5, which is going to be the same thing it was before, 3.375. So if I calculate the cube of this one, I'm going to be very, very careful as I do this. It's 4 times 3 is 12 times 5 is 60. So this should be 60 units cubed. And just because I got the wrong one last time at the beginning and it caused me problems down the road, I'm going to double check my work. 4 times 3 times 5 is 60 units cubed. Now if I want to calculate the volume of the other side, I'll just put it into the K cubed value, 3.375, and times 3.375 gives me 200.5 units cubed. Now if I multiply these three values, I should get the same thing. If I do 6 times 4.5 times 7.5, it should equal 200.5. So 6 times 4.5 times 7.5 does equal 200.5. I double checked my work there. It worked. Now there's a third way I could do this. I could say 6 raised to 4 as the volume of the second, which we call x, because that's what we know to begin with, is to 60 units cubed. Now when I put the units cubed in there, remember it's going to remind me that this is supposed to be cubed and that's supposed to be cubed. 6 cubed equals 216. 4 cubed equals 64. So 216 over 64 equals x over 60. So now cross multiply. 216 times 60. Sorry about that. I'll fix that. 216 times 60 equals 64 times x. So 216 times 60 equals 12,960 equals 64x. Then we'll divide by 64 and we get x equals 202.5. Check my work twice, 2 ways there, and got the same answer all 3 times. Let's move on to the next slide. So here we have a cone. So if I were to look at this cone and I wanted to find out what we were working on, I'm going to say image over pre-image is going to allow me to find my K factor. So if the image is 3.6, I could have done 1.5 also. That would have been fine. And the pre-image is 1.2. I do 3.6 divided by 1.2, and we get a K value of 3. What would the area's K value be? Remember, we're going to square it for area, so the K value would equal 9. What about the volume? What would the volume's K area be? Well, it would be K cubed. So if K is 3, 3 times 3 times 3 is 27. So that's how you find the K value for perimeter, K value for area, and K value for volume. All right, now let's put it into practical application once again. This time we have a couple of cylinders, a couple of coffee cups, and you can see Dad's coffee cup is bigger than Mom's coffee cup. I got this off of a website for geometry problems on proportional surface areas and volumes. So if I were to look at this, I'm going to say 6:4. Then our K value would again be 1.5. That's the third time on this slide I've had a K value of 1.5. So do you remember how to, one of the questions, when you get a question like this is, do you remember how to calculate surface area and volume of a cylinder? Well, surface area of a cylinder is found by 2 pi r squared plus 2 pi r h. And volume is calculated by pi r squared h, base times height. Okay, so that's how you calculate the values. So let's kind of work it out. Let's work with the pre-image, Mom's coffee cup first. Okay. Oops. So if we calculated surface area, we'd say that it's 2 times pi times r squared. R equals 4. So 2 times pi times, r equals 2. Radius equals 2. Glad I caught that early on because I made a mistake similar to that earlier. Today's lesson. Don't want to make that again. So 2 pi r squared plus 2 times pi times r, which is 2, times the height, which is 4. That'll give us our surface area. So that would be 2 squared is 4. 4 times 2 is 8 pi plus 2 times 2 is 4 times 4 is 16 pi. So those are like terms, so I can add them. And when I do, I'm going to get 24 pi equals the surface area. Wonderful. Now I want to calculate the volume, which is pi r squared h equals the volume. Well, we already determined that r was 2, so it would be 2 squared times h, which would be 4 times pi equals the volume. So the volume would equal, in this case, it would equal 16 pi. Okay. All right. So if we were looking for surface area, we take and we're going to do a K value of square it. So if we did for surface area, we'd do 1.5 squared which is 2. So for area, excuse me, we're going to have K squared, which is 2.25. And for volume, we're going to do K cubed, which is equal to 3.375. So if our surface area was 24 pi for Mom's cup, for Dad's cup, we'd multiply that by 2.25, and we'd get, we're going to do 24 times 2.25, and we'll get 54 pi for the surface area. And for the volume, we'll do 16 times 3.375, and we're going to get 54 pi units cubed for the volume. So we ended up with the same surface area and volume for Dad's cup, because the volume is going to increase greater rate than the surface area. All right. Hopefully these kind of help you as you're walking through stuff. That comes to our end of our lesson. As we do 11.5, page 552, Tonight, for 2020 only, that's Corona year, the COVID-19 year, we're lowering the homework standard, so 2 to 8, 11, 12, and 23, instead of 1 to 12, 23, and 24. Just trying to help you out here. That's your homework for tonight. I won't see you again tomorrow. We're getting ready for